Today we're going to talk about statistics, distance, and midpoint. So on number 1, the table shows the test grades for 2 different class periods. We want to find the difference in the means of the 2 periods, round to the nearest tenth. So we're going to put these into our calculator and find the means for each of these. So first we're going to click the stat button, we're going to click edit, and we're going to put all of period 1 into L1 in our calculator. So now we have all of period 1 into L1. We go back to stat. We're going to click calc, and then we're looking for 1 bar stats. And when we do that, these numbers show up. So we're just looking for the mean. So that is our top number here, 91.6. We're going to go through the same process for period 2. So for period 1, our mean was 91.6. For period 2, our mean is 82.4. And it says find the difference. So we're going to subtract them and we get 9.2. All right, number 2, which of the following statements does not imply causation? Remember, causation means that one thing causes the other. Sometimes things can be correlated, but they don't actually cause each other to happen. So letter A, studying leads to higher grades, exercising results in greater strength, elevation increase is responsible for temperature decrease, and the sale of gloves is positively correlated to the cost of heating a house. All right, so we look at the vocab here. Leads to, results in, is responsible for. Those are all implying causation. And so that means that whatever study was done to get these results, they proved that studying was the cause of higher grades. Exercising was the cause of greater strength. Elevation increase was the cause for temperature decrease. So those kind of vocab words tell us that causation has occurred. Letter D just says that they are positively correlated. So they could still cause each other, but this study did not prove that they caused each other. It just proves that they were positively correlated. And if we look at the variables we're using, the sale of gloves and the cost of heating a house, just because people buy more gloves does not mean that your house is going to cost more to heat. They are positively correlated because both of those things happen at the same time in the winter, but they do not cause each other to happen. So this would be the one that does not imply causation. Right, number 3, choose all of the following that describe the correlation coefficient for this scatter plot. So if we try to draw a line of best fit, all of these dots are very, very close to the line, which tells us it's going to be a strong correlation. And it is a positive slope. So this is a strong positive correlation. As one thing goes up, the other one also goes up. Right, we're going to use this box plot to determine if there are any outliers. So for outliers, we use 2 formulas, Q1 minus 1.5 times the IQR, and Q3 plus 1.5 times the IQR. And these will tell us where we need to stop on our box plot. And if there's anything beyond that, that will be an outlier. So Q1 is the beginning of our box, so that's at 45. And Q3 is the end of our box, so that's at 60. So we need our IQR, so we take 60 minus 45, and we get 15. So we say Q1, in this case, Q1 is 45, minus 1.5 times our IQR is 15. So 45 minus 1.5 times 15 gives us 22.5. So that is the lowest we can go without it becoming an outlier. And then we do the same thing on the upper side. So 60 plus 1.5 times 15. And that will give us how high it will go without becoming an outlier. And here we get 82.5. So anything between these two numbers is fine, and those two numbers by themselves are fine, but anything beyond that, if it's lower than 22.5 or higher than 82.5, it's going to be an outlier. So 22.5 is about right there, and 82.5 is about right there. So we do know we have at least two outliers. We don't know how many dots are on either side of these lines, but what we do know is that there is at least one minimum and one maximum that would be an outlier. So we have at least two outliers at 15 and 90. Right, on number 5, we're going to find the linear regression equation and the correlation coefficient for the table. And we're going to round to the nearest hundredth, and then we're going to describe what that correlation coefficient means. Then we want to find lin-reg. This is for linear regression. So when we do that, this is what shows up. So we have our equation, and then it gives us the A and B that we can plug into our equation, and then we're looking at the R value. Don't care about R squared right now. Right, so we have our equation and we have our R value. So now we want to describe what that correlation coefficient means. So remember, on a number line, correlation coefficient goes from -1 to 1. As it gets closer to 0, that is very weak. -1 and +1 are very strong. It just depends which direction it's going. So this is strong in the negative direction. This is strong in the positive direction. So -0.76 is fairly strong. That's definitely closer to -1 than it is to 0. So this would be a strong negative correlation. Right, number 6. This graph is based on the cost of a flight and the distance it travels. We want to say if it's positive or negative. This has a positive slope. So what that means is as distance increases, the cost also increases. So that's our slope. So as distance increases, the cost also increases. If it was a negative slope, that would mean as one goes up, the other one goes down. So what is the predicted cost of a flight that travels 1,000 miles? So if we look at our graph, since we don't have an equation to be able to plug something in, we'll look at 1,000, we'll go up to where it hits the graph. And that's in between 100 and 150, so that's about 125. All right, on number 7, the diagonals of a rhombus ABCD meet at 0 or at O. We want to find the coordinates of point O. So we're finding the midpoint between A and C. So for our midpoint, we take our X's and add them together and divide by 2. Then we take our Y's and we add them together and divide by 2. So we're really just finding the average of both of the coordinates. So we take -4 plus -5 over 2 and 10 plus 3 over 2. And so here we get -9 over 2 and 13 over 2. You can leave it as a fraction, or sometimes if it's multiple choice, they may write it as a decimal. So it would be -4.5 and 7.5. Would be the midpoint between those two coordinates. Right, Jerry and Jean are jogging different paths, but starting at the same location. Jerry jogs at a rate of 5 miles per hour, traveling from point A to point R, to point S to point C. Jean jogs directly from point A to point C at a rate of 3 miles per hour. Which jogger reaches point C first? So we need to find how many miles each of them ran, and then we can figure out how long it took them to get to that location. So Jerry went from A to R, and then to S, and then to C. Since these are all vertical and horizontal lines, we can just count the boxes. So he went 2 miles, and then 1, 2, 3, 4 miles, and then 1 mile. So he went a total of 7 miles. Okay, and Jean is a little bit more difficult because hers is a diagonal line. So we are going to use our distance formula. And remember, distance is kind of like Pythagorean theorem. We're doing a squared plus b squared. But to get our a and our b, we just subtract our x's and subtract our y's. So we'll subtract our x coordinates, subtract our y coordinates, and we'll see how far Jean went. So 6 minus 2 gives us 4 squared plus 3 squared. So that's 16 plus 9 is 25. So Jean ran 5 miles. So obviously the more direct route straight from A to C is fewer miles. We want to see which one which one reached C first. So we know that Jerry is jogging at 5 miles per hour. So since he ran for 7 miles, we're going to multiply it by a fraction. This is, since we want to cancel out miles, we're going to put it in the bottom, miles per hour. And he's running at 5 miles per 1 hour. So we actually end up dividing these. 7 divided by 5 gives us 1.4 hours. Right? And then Jean, she's running at a rate of 3 miles per hour. So again, we're going to cancel out miles. So we put it in the bottom. So 3 miles per hour. So 5 over 3 is 1.6. And so Jerry got there first because it took him less time. It took him only 1.4 hours instead of 1.6.